Let's think about the sine function in the following context. Kristen boards a Ferris wheel at the 3 o'clock position and rides the Ferris wheel for 1 full rotation. The radius of the Ferris wheel is 14.5 meters long. So let's start by drawing a diagram of this. So we have our Ferris wheel here, the legs of the Ferris wheel, here's the ground, and we know that the radius of this Ferris wheel is 14.5 kilometers long. And so Kristen boards the Ferris wheel at the 3 o'clock position and then starts rotating counterclockwise. And we're going to draw kind of like a snapshot of this. We're going to imagine, you should imagine her rotating around this Ferris wheel, but I can only draw a snapshot of this. So when we draw a picture, you kind of just draw a freeze frame of it. So we'll draw this angle centered at, whose vertex is at the center of the Ferris wheel and whose rays subtend this path that Kristen travels. So let's just say that theta, we'll say this variable theta represents the number of radians that angle has swept out since the Ferris wheel started rotating. And so we know that the sine function tells us about the vertical distance of that terminal point measured in radius lengths. And so when theta radians have been swept out, Kristen is sine of theta radii above the center of the circle. And if she's sine of theta radii, or radius lengths above the center of the circle, and each radius length is 4.5 kilometers long, then she is 14.5 times sine of theta kilometers above the center of that Ferris wheel. Now, let's switch things up a little bit. Let's say that s, the variable s, represents the number of meters that Kristen has traveled along the circular path since the Ferris wheel started rotating. Remember that radian angle measure, like this theta, is the measure of the subtended arc length in units of the radius of the circle. So theta is really equal to the measure of the subtended arc length s in units of the radius of the circle. So theta is equal to s divided by 14.5. This will be true for all values of s and theta. What this tells us is, anytime we see theta, we could actually just replace it with s divided by 14.5 because both of those represent the number of radians swept out since the Ferris wheel started rotating. So in our previous expressions, we could actually just replace thetas with s divided by 14.5. So s divided by 14.5. Those are still true. We didn't really change that much. All we did was change what we're using as our input variable. Now we're just expressing things in terms of s instead of in terms of theta. But since theta equals s divided by 14.5, we didn't really change the quantity that we were representing.